Alright, it's time for us to analyze the benzylic acid that we produced by the benzylic acid rearrangement. And I've got my balance here. Since we're weighing this at the same moment that I'm transferring it, we can just put this on the balance and hit the 0 button, so we don't need to record the mass separately of the glass. Alright, so the balance is zeroed with the watch glass on there. And so now I'll just transfer the product onto this watch glass, and that should be all we need to do for isolating this product today and weighing it so we can calculate a % yield. I'm trying to scrape off the powder off the magnetic stir bar here. So I'm going to try to do this at an angle that you might be able to see this. Actually, the powder seems a little bit moist, but I'm not using this balance for anything else for the next couple days, so I'm just going to put this on the tabletop here, and I'll weigh it periodically and we'll see what the mass is. Of course, when it reaches constant weight, that's when it should be the lowest mass and all of the water should be evaporated. So this might need to go a few more days, and it's Tuesday today, so maybe by Thursday it'll be fully dry. Not quite as free-flowing as you would expect a dry powder, kind of like flour. It's more like clumping together, so I think it's a little bit wet still with water. It always takes water a little bit longer to evaporate from a organic solid than it is for something like methanol or ethanol, which have lower boiling points and higher vapor pressure. So that's a pretty clean filter paper there. And once again, just need to get around the perimeter here. There's always a little bit of solid that builds up around the edges. So I won't remember this, so I'm going to just take the camera around and measure the mass here that we have, and then I'll check it again on Thursday, and should be good. Okay. One other reason for transferring it to the watch glass is to kind of increase the surface area, and that will allow the water to evaporate a little bit better. So let's bring the camera around, and there's our mass. Okay. Seems quite high in my mind. I don't remember what we started with, but there's a lot of water here, so we're gonna come back on Thursday. You know, I'll just put this off to the, well, I need to keep this on there, don't I? We'll come back Thursday and we'll see what the final reading is. All right, the substance has been sitting here for more than a day, almost a day and a half, and that's the mass there with the watch glass, and it's a nice, you know, white powder. It's clumped up, of course. So now we'll do the melting point. So here's our benzylic acid, and we've got our microcapillary that will load up. As usual, we want about 2 to 3 millimeters depth material in there. Tap this on a surface, and this is not going down. Don't know if you can see that. It all just came out the top. Try this again. Sometimes jamming in all the full amount at once doesn't work, and you have to do it in portions, a millimeter at a time or so. This material doesn't seem to be falling down too well. Yeah, it just came out again. Got about half of what I need in there right now, so let's try to get the other half in. Gotta be careful when doing this. Sometimes you can crack the glass and it can stab into your thumb or something, like that blood test they do. Okay, I've got, you know, more than I need there, about 4 millimeters. But let's go ahead and do that. So I've got my melting point apparatus here. Once again, I'll have one camera pointing at the temperature reading here, and the other camera pointing down the viewpoint here where my microcapillary is placed into an aluminum block that's heated. You want to use a melting point from one literature source. Many you know, melting point literature references might have different numbers, so you want to use one number. If it's 148 to 149, use that. If it's 150 to 151, use that, okay? Maybe in your comment section, mention which reference you're using for the melting point. So I'll come back when this is ready and we'll take a melting point. All right, using different devices for recording the temperature, but it reads 138.1 degrees Celsius right now. I've got my tube in here. It's a nice white crystalline powder. And we'll go ahead and start heating this guy up here. Ideally, you want to raise the temperature about 1 degree Celsius per minute. I tend to do it way too fast on the videos, but we'll go ahead and get our data and be good to go. As always, you may fast forward through this video and rewatch it a few times to get to the points where you think you have the beginning of melting and final point of melting. You don't need to play the video really slow for the full 15-20 minutes, so do what you need to do. And thanks for watching, and please do consider subscribing. Okay, well, I used my laptop computer to film the temperature reading on the melting point apparatus, and apparently when my laptop went into the screensaver mode, it just decided to take a still image for several minutes, so it never did record the temperature going up. And so there's no point in watching this video. This experiment was not adequately recorded. So on your lab reports, you may go ahead and place NA, capital N, capital A, which stands for not applicable. We cannot do this measurement in the small amount of time remaining. So yeah, but anyways, that's how you would do the melting point, and hopefully you know how to do this for advanced classes that you might do in the future. Take it easy.